Hey, good friends, we are going to start today talking about section 2.3. We're going to be dealing with addition and subtraction of decimals. Okay, so addition and subtraction of decimals, here we are. Notice this very, very handy figure here. No calculator, please. So I don't want you to use a calculator when you're doing this. We are going to use a technique where we estimate. And what the estimating does is it helps us to make sure that our answer makes sense. And it's like another level of checking to make sure that our answer is as close to correct as possible as we're working through it. So let's see what we've got. So here, when I look at 32.5 plus 19.6, I would say this is kind of like really close to the number 33. This is my estimation portion that I'm doing. And this number is really close to 20. What I'm doing is I'm rounding. When I add 33 and 20, I get 53, which was pretty easy to do in my head. So I know that when I add up 32.5 or 32 and 5/10 and I add up 19 and 6/10, I need to get a number that's pretty close to 53. So now I'm going to do my addition. I take the 32.5 or the 32 and 5/10 and I line it up by its decimal with the other number 19 and 6/10. Now I'm going to add like I used to add back in the day, carrying values. So 5 and 6 is going to give me 11. 1 down here, I carry my 1. 9 and 2 gives me 11, plus 1 more gives me 12. 2 down here, carry my 1. 1 plus 3 plus 1 is 5, and I get 52.1. Is that a decent estimate? Yeah. It's close, it's in the ballpark. I'm not worried about the fact that if I round 52.1, I won't get 53. What I'm looking for when I do my estimation is to make sure my answer is close, make sure it makes sense, and to me that does. Would you like us to do this together? I don't think you do. You want to do it on your own. You can't wait to get started. All right, here's what I'm going to ask you to do. Finish up this page, just this one. We're going to do 2 pages, but finish up this page. When you're done, click unpause because you're about to pause me and I'll have the answers and we can talk about them together. All right, see you soon. Well, that took a few minutes, but here we are and we're looking at our answers. And so what I tried to do, I realized that it might be better to have my estimate in red and then my actual work for the problem in purple. That's just what I chose to do. And so what I saw was that, my answer was 7 for 3, 7.39. Which is pretty close for my actual answer. 13, 13.45, 10, 9.6, 393, 393 and 41 hundredths, 21 and 21 and 6/10. So I felt like the answers were pretty close, right? Subtraction is always a thing because you have to remember to borrow. I'm going to point out these last 2 situations here that I think are worth mentioning and worth pointing out. Obviously, if you have any other questions, you could actually email me if you want me to do a specific video for you because you're like, I don't know what's going on, Dion. Let me know. I will do the best I can to make sure you get that. But looking at number 9 and number 10, I think this might have been the place where a lot of people had a little bit of reservation or maybe a little bit of challenge. What we needed to do, and this is a little blurred, so I'm going to rewrite it. You have your 8.03 and you are subtracting, or 8 and 300ths, and you're subtracting 4 and 715 thousandths. What you need to do is, and I use green because it's a good friend, our good friend, the placeholder 0, comes in and fills in that place. And what it does is it balances the 2 numbers so that I can feel more confident subtracting. So now I'm going to subtract. Well, what happens when I'm trying to subtract 5 from 0? I can't. I do my borrowing thing. This 3 becomes a 2. And I get a little bit to help me out here. So 10 minus 5 gives me 5. 2 minus 1 gives me 2. Again, I have a situation where I need to borrow, so I go next door, say, 8, give me some. And 8 gives me 10 tenths, right? Because if I take 1 is 10 tenths. Making sense, maybe? I don't know. We'll see. We'll see. We'll see when I talk to you soon. And so oh, this should be a 1. Somebody was going to call me on it. All right, I found it. Found my mistake. Okay, so we get 3 and 315 thousandths. All right, and similarly we did the same thing where we needed to put a placeholder. Let's go ahead and introduce the next page. So this is the last page of your classwork, and then I'm going to tell you your homework and you can get started. All right. For problems 12 and 13, we're going to round the more precise measurement to match the less precise measurement. So let's take a look at some of our information here. So in number 11, in 1999, Maurice Green set a new world record for the 100-meter dash running the race in 9.79 seconds, or 9 and 79 hundredths, 9 and 79 hundredths of a second. Until then, the record had been held by Donovan Bailey, who ran the race in 9 and 84 hundredths of a second. How much faster was Green's time? Well, when we talk about faster, we're looking at the difference here. And so this is a situation where we're going to subtract. And that gives me this. And so what I need to do is handle my business. I need to subtract. So I'm going to borrow here. In this case, it looks like I need to. 9 from 14 is going to leave me with 5 here in the hundreds place, and 0 here in the tens place, and 0 in the ones place. So how much faster was Mr. Green than Donovan Bailey? The difference was really 5/100ths of a second, which is pretty interesting. Let's look at number 12, because number 12 is what the directions for here. It says for problem 12 and 13, we're going to round the more precise measurement to match the less precise measurement. So let's see how we can do that. In 2000, in the 2000 Olympic Games, the United States women's 400-meter medley relay team won the swimming event with a time of 300 minutes and 58.3 seconds. In 2004, the United States women's team took second with a time of 3 minutes and 59 and 12/100ths of a second. How much faster was the 2000 team than the 2014? So now that we have the information, what we need to figure out which one is the more precise and which one is the less precise measurement, and then we're going to make sure we round everything to that when we're done. So when I'm looking at the information that they gave us, this is really the basis of what we're comparing, right? Which one's more precise, which one's less precise. And this one is less precise. Why? Can you guess why? This 58.3, the 3 minutes and 58.3 seconds, as opposed to the 3 minutes and 59.12 seconds, this one is less precise. And the reason why is very simple. We go to the next decimal place. Like this could be 0.34, this could be 0.32, this could be 0.30009. They did not go out to a further decimal place, so it is less precise. All right. So when we write our answer down, we're going to write it down to, we're going to round to the tenths place. That's ultimately what it means. So you round to the shortest, to the, yeah. All right. I'm going to keep it going. So we have this. Let's go ahead and see how much faster was the 2000 team than the 2014, which is a subtraction problem very similar to the last one. So we're going to take 59.12 and we're going to subtract 58.3. I can put in a 0 there just to calculate, just to, as a placeholder. 2 minus 0 is 2. Sorry about that. Got confused there. Don't worry, we can do it. We can do it, I promise. So we get 2 here. I need to do a little bit of a borrowing situation to figure out the tenths place. But when I do that, I get 8. So I have 0.82 seconds, right? But we were asked in the beginning to round to the place of less precision. So we're going to round to the tenths place, and we're going to get as a final answer 0.8 seconds or 0.8 of a second. Notice I did not involve the 3 minutes because they were both 3 minutes and they cancel each other out. All right, I'm going to let you guys finish this page, and this is the last of your classwork. Finish this page, these last 2 problems. Check your answer with me as after you unpause me, because you're about to pause me, and then I'll let you know your homework assignment. I'll see you guys soon. All right, so let's settle in and answer these last couple questions. And for the first one, part A, we got that Olga Kozinskova. Olga Kozinskova was the person with the greater distance, clearly, just looking at which number was greater. And then finally, by how much, we had to do a bit of subtraction. I didn't actually do the problem correctly. I'm now looking at it. I got 38.2, but 38.82, but this 2 has to go away. Do you guys remember why? Because we know that the least precise number was this one that went to the tenths place, so we had to stop at the tenths place. That's as per the directions here, right? The directions asked us to make sure our answer matches the less precise one. All right, and the other thing we need to look at here is this perimeter situation. So we remember perimeter is 2 times the length plus 2 times the width. So I started off saying, okay, here's the length. 2 times the length is 85. And this is, when I have parentheses here, it actually means multiplication in this case, but I forgot to put my little asterisk multiplication sign, so I'll stick those in. So 2 times 85, I can do that. 2 times 85 centimeters, and 2 times 2.6 meters. But meters and centimeters are not the same. And if you look over here, how could this be 85 in length and this be 2.6 unless we were using different units? As we see, we've got centimeters and meters. So it behooves us to actually change our meters to centimeters. Now, 1 meter is equal to 100 centimeters. Therefore, if I multiply this 2.6 by 100, I get 260 centimeters. Make sense? I hope so. I do hope so. So now that I've done that, I'm rocking out 2 times 85 plus 2 times 260 gives me 170 and 520 respectively. When I add those up, I get 690 centimeters. Could somebody tell me what the meter version of this? If 1 centimeter, well, if 1 meter is 100 centimeters, how many meters would I have if I wrote this in terms of meters? Would you? Yeah, you got it. Just kidding. I don't know if you said it or not. 9 meters, 6.9 meters, because we'd have to divide this number by 100. And so we get, yeah, making sense? Sort of, kind of. Remember, if we divide it by 10, it's like moving the decimal place back one time, or to the left one time. If we divide by 100, it's like moving it back twice. I am going to skip this page for now. We might pick back up with it on Monday, but that is all for your classwork. So the next thing we're going to get into is your homework packet. So looking at your homework packet, we just did section 2.3. I'm going to slide this over so you can see a little bit better. For homework tonight, or if you can start it in class, if you will, you did this math box last night. If you hadn't done it before, you're going to do study link 2.3 sports record, and notice there's no calculator here, and you will also complete for me math boxes from lesson 2.3. And if you've done everything else and you are good to go, go ahead and get started on this now in class. I can't wait to see you guys on Monday. I hope that all is well and you have a delightful weekend. I will talk to you soon, 6B. Bye-bye. Okay, not bye-bye so far. Wait a minute. I forgot to tell you. I think we should have a quiz on section like 2.1, 2.2, and 2.3. Not on Monday, but maybe on Tuesday. Sound good? If you'd like, write a little comment underneath the underneath this assignment link and tell me what you think about a quiz on Monday or Tuesday, but I'm thinking Tuesday. All right. I look forward to seeing you. Now, for real. Bye-bye. Bye-bye, 6B.